German engineers were the best in the world, so why did they laugh themselves silly at the idea of American radar? In 1941, the Allies were flying blind, but a tiny piece of metal, ridiculed by the Axis, would change the world forever. You've probably heard of radar, but you may not know the one secret that made the Axis leadership panic. In the darkest days of 1941, Allied bombers flying into the heart of Germany were doing so almost blind. They were flying on hope and a prayer, navigating by the stars when they could see them and by dead reckoning when they couldn't. The losses were staggering. For every bomb that hit near a target, countless more fell harmlessly on open fields, and too many brave young men, boys really, never returned. They were being torn from the sky by flak and fighters because they had to fly low and slow in broad daylight just to find the target. At night, it was even worse. They were trying to hit a factory, and they were lucky if they hit the right city. The German high command knew this. They looked at the technology of the day, radar included, and they knew its limits. So when whispers started about a new Yankee device, one that could supposedly paint a map of the ground from 20,000 feet in total darkness through solid clouds, they laughed. They ridiculed it. It was scientifically impossible. It was a fantasy. But what the Axis engineers didn't know, what they couldn't possibly have known, was that the Allies were holding a secret. It was a piece of technology so revolutionary it would be guarded more closely than the atomic bomb. And it would not only stop the ridicule, it would turn that laughter into pure, cold panic. This is the story of the one device that let Allied airmen finally see in the dark and why the Axis thought it was a joke until it was far too late. To understand the ridicule, you have to understand the world as they saw it in 1940. Radar itself wasn't the secret. In fact, both sides had it. The British had their chain home system, a wall of massive towers that saved them during the Battle of Britain. The Germans had their own excellent systems like the Freya for early warning and the Würzburg for directing their anti-aircraft guns. These were brilliant pieces of engineering. But they all shared the same fundamental limitation. They operated on relatively long wavelengths, in the meter or decimeter range. Think of it like trying to see with a flashlight that throws a beam as wide as a barn door. You can see the barn, certainly. You can tell something big is out there. But can you see the latch on the door? Can you see the hinges? Not a chance. This was the problem for Allied bombers. Their early airborne radar, called ASV or air-to-surface vessel, was a godsend for finding U-boats on the surface of the Atlantic. It could pick up a surfaced submarine from miles away. But when that bomber flew over land, the image on the screen was just a smear, a messy blob of green light. The long wavelengths of the radar would bounce back from the ground, but the signal was so coarse, so blurry, that it couldn't tell the difference between a river and a road, or a field and a factory complex. It was all just ground. To the Germans, who were masters of this type of long-wave radar, the idea of using it to map terrain was absurd. It would be like trying to paint a portrait with a paint roller. They knew the physics, and the physics as they understood it said it was impossible. This is where the story takes its turn, and it's a turn that hinges on desperation. In the summer of 1940, Britain stood alone. Prime Minister Winston Churchill knew that to survive, let alone win, they needed a miracle. They needed technology that was decades ahead of its time. So he authorized one of the most important missions of the entire war, the Tizard Mission. It wasn't an invasion, it wasn't aspiring, it was a small group of scientists sent to the still neutral United States, carrying a locked black box. Their instructions were to give America Britain's most valuable scientific secrets, in the hopes that the industrial might of the US could turn them into weapons of war. When the American scientists at the new top-secret radiation laboratory at MIT, the Rad Lab, opened that box, they were stunned. Inside was not a plan, not a blueprint, but a working prototype of a device that shouldn't exist. It was called the cavity magnetron. It was a humble-looking piece of copper, not much bigger than a man's fist, but this little device was the miracle Churchill had been praying for. It could generate microwaves, radar waves that weren't meters long, but centimeters long. This was the breakthrough. This changed everything. Why were centimeters so important? Let's go back to our flashlight analogy. The cavity magnetron didn't just create a flashlight beam as wide as a barn door, it created a beam as sharp and as fine as a pencil. And with a pencil-thin beam, you can suddenly see the details. You can see the latch. You can see the hinges. You can trace the outline of the door itself. When you send out a radar pulse in this centimetric band, the echoes that come back are incredibly detailed. Water, which is flat, scatters the signal away and looks black. Buildings with their sharp 90-degree angles bounce the signal right back and glow brightly. Roads, fields, rivers, and coastlines all return a different, distinct signal. The moment of truth came in 1941, in a prototype bomber flying over New England. The engineers at the Rad Lab had built a system, codenamed H2S, and they weren't sure what they would see. They flipped the switch, and there, on the cathode ray tube, a glowing green image appeared. It wasn't a blob, it wasn't a smear. It was a recognizable, crude, but unmistakable map of the coastline below. One engineer famously looked at it and said, "It's a map. It's a map." The impossible had been done. This is the kind of story that reminds us of what that generation was capable of. Many of us had fathers or uncles who served, and they often didn't talk about what they did. But this was the kind of silent, brilliant work that gave them the edge they so desperately needed. If you find this piece of hidden history as fascinating as we do, you might consider subscribing to the channel. We make it our mission to dig up these stories that get lost in the footnotes, because we believe they deserve to be told. The development from that first bloody map to a war-winning weapon was astonishingly fast. The British, who had invented the Magnetron, were the first to put it to use in bombers under the H2S name. The Americans, with their industrial power, refined it and produced it in massive quantities as the H2X radar, which operated on an even shorter 3-centimeter wavelength, giving it even better resolution. Now, imagine you're a 20-year-old kid from Ohio, a bombardier in a B-17 Flying Fortress thousands of feet above a blacked-out Germany, completely covered in thick clouds. Your teeth are rattling from the cold and the vibration of the engines. You haven't seen the ground in 2 hours. You have no idea where you are. But in front of you is a small, round screen. On that screen, you see a faint, glowing line appear. It's a coastline. You know from your briefing that you're approaching the German coast. A few minutes later, a bright cluster appears. That's the city of Hamburg. But you're not aiming for the city. You're aiming for the shipyards. Your navigator guides you in, and as you get closer, the glowing cluster resolves itself. You can see the dark, non-reflective shape of the River Elbe cutting through the city, and right on the bank, a collection of intensely bright spots: the docks, the warehouses, the U-boat pens. All of this through 10/10 cloud cover from 5 miles up. You're no longer blind. You're the first man in history who can see in the dark. This technology changed the very nature of the strategic bombing campaign. The British RAF used it to launch the devastating raids on Hamburg, Operation Gomorrah, which created a firestorm that crippled the city. Because the H2S radar allowed their Pathfinder crews to mark the targets accurately, even through smoke and clouds, the main bomber force could drop their payloads with a precision that was unheard of just months before. The Yankee H2X radar, installed in Amex B-17s and B-24s, allowed the 8th Air Force to conduct effective bombing missions in the overcast European weather that had previously grounded them. Suddenly, there were no weather-safe days for German industry. The bombers could come anytime, day or night, rain or shine. But this brings us back to the Ridicule. For the first year of its use, the Germans were completely baffled. Their defenses were built around their Wurzburg gun-laying radars, which were excellent, but they operated on a 53-centimeter wavelength. Their scientists had tested microwave band radar and abandoned it. They believed the power output was too low and the technology too complex to be practical. They had concluded, with typical German engineering certainty, that it was a dead end. So when their night fighter crews started reporting that British bombers were still accurately bombing targets through impossible weather, the high command didn't believe it. They assumed it was a new kind of navigation beam or just dumb luck. The idea that the Allies had a small, lightweight, high-power, high-resolution mapping radar in every bomber was to them laughable. The laughter stopped on a cold night in February 1943. A British Sterling bomber, part of a raid on Cologne, was shot down near Rotterdam in the Netherlands. This bomber, unlike so many others, was not completely destroyed. It crash-landed, and its H2S unit, though damaged, was largely intact. A German technical team, led by a man named Wolfgang Martini, was sent to investigate the wreckage. When they found the device and realized what it was,
The mood in Berlin changed from ridicule to sheer panic. They called it the Rotterdam device. German scientists were horrified. They realized in an instant that the Allied technology was not just ahead of theirs, but in a completely different league. They had nothing that could even detect these 3-centimeter band signals, let alone jam them. All their existing radar detectors in their night fighters were useless. The Allies owned the microwave spectrum, and by owning that, they owned the skies. The head of German radar development, in a state of shock, reportedly told Hermann Göring, "We must frankly admit that in this field, the British and Americans are far superior to us. I have to admit, it's a bitter pill to swallow." The ridicule was over. A frantic, desperate race began in Germany to try to catch up, but they never would. The impossible Yankee device was now the single biggest technological threat they faced. This shift from total confidence to total panic is a powerful lesson. It's a reminder that overconfidence, believing you know all the answers, is often the first step to failure. The Axis were brilliant, but their brilliance became arrogance. They assumed their way was the only way. This is a story that has repeated itself throughout history, in war, in business, and in our own lives. It's the kind of lesson that stays with you. We believe these lessons from the past are more important than ever. If you agree, one of the best ways to support this channel is to simply share this video with a friend or family member who you think would appreciate this history. It costs nothing, but it truly helps us keep these stories alive.
Now, the impact of the Magnetron wasn't just limited to bombing. It fundamentally changed the Battle of the Atlantic. German U-boats had been hunted by long-wave radar that they had to counter. They invented a detector called METOX that could hear the Allies' radar signals long before the radar could spot the U-boat. The U-boat captain would hear the ping, 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 and would have plenty of time to dive, disappearing before the plane got close. This was a huge problem. But the Magnetron changed the game. The new 10-centimeter radars were invisible to the METOX detectors. A U-boat captain would be surfacing at night, feeling perfectly safe, while an Allied plane 10 miles away was tracking him on a bright, clear screen. The plane would get closer and closer, and the U-boat crew had no idea. But there was one last problem. In the final mile, as the plane dived for the attack, the radar signal would get lost in the clutter of the waves on the sea surface. The plane would lose the U-boat in the darkness. The solution was another simple, brilliant invention: the Lee light. This was a powerful, automatic searchlight mounted on the plane. The moment the radar lost the U-boat in the clutter, the Lee light would snap on, instantly illuminating the submarine. The U-boat crew, blinded and stunned, had only seconds before the depth charges fell. This combination, the high-resolution magnetron radar and the Lee light, was utterly devastating. U-boat losses skyrocketed. Admiral Donitz, the head of the U-boat fleet, was mystified. He wrote in his war diary about the sudden, terrifying increase in attacks, how his crews were being caught on the surface at night with no warning. He couldn't understand how it was happening. The impossible technology was not only mapping their cities, it was sinking their submarines and winning the Battle of the Atlantic. The men who operated these systems, these young navigators and radar operators, were fighting a different kind of war. It wasn't just about courage and reflexes. It was about trusting this new, almost magical technology. They were the first generation of electronic warriors, and the work they did saved countless lives by ending the war sooner. It's tempting to think of this as just a story about bombing, but the implications were so much broader. The H2X radar, the Yankee version, became a critical tool for mapping in all sorts of theaters. In the Pacific, B-29 superfortresses used H2X, also known as APQ-13, to navigate the vast, featureless expanses of the ocean. It allowed them to find small, pinprick islands in the dark and to find their targets in Japan, a country whose weather was notoriously unpredictable and often cloudy. It's not an exaggeration to say that the strategic bombing of Japan, including the missions that led to the end of the war, was only possible because of this terrain mapping radar. Think about the sheer scale of this. A technology that the enemy's brightest minds had dismissed as unworkable and a waste of time was now the primary navigation and bombing tool for the entire Allied air fleet. It allowed them to map enemy territory from a safe altitude, to identify targets, to see through weather, and to hunt the enemy's most dangerous naval weapon.
The Ridicule of 1941 must have seemed like a very distant, very bitter memory to the German High Command by 1944. They were living in a new reality, one defined by an invention they laughed at. The story doesn't end in 1945. The legacy of that impossible device is all around us, every single day. After the war, the scientists at the Rad Lab, now heroes, went back to civilian life. One engineer, Percy Spencer, was working at Raytheon, which was mass-producing magnetrons for radar sets. One day, he was standing in front of a live magnetron tube and noticed that the candy bar in his pocket had melted. He was a curious man, so he tried an experiment. He put some popcorn kernels near the tube. They popped all over the lab. The next day, he brought in an egg. It cooked so fast it exploded in a colleague's face. What he had discovered, thanks to the cavity magnetron, was the microwave oven. That piece of wartime technology, born from desperation and ridiculed by the enemy, is now sitting in millions of kitchens around the world. Every time you heat up a cup of coffee or make a bag of popcorn, you are using a direct descendant of the Rotterdam Gerät. And it doesn't stop there. Modern weather radar, which lets you see a storm front moving in on your local news, that's centimeter radar. The air traffic control systems that guide our planes safely, the radar guns police use to check speed, even the Wi-Fi in your home, all of it operates in the microwave spectrum that the magnetron opened up. We live in a world built by that impossible idea. It's a powerful reminder that sometimes the things that seem most ridiculous are the very things that are about to change the world. The Axis engineers were not stupid. They were among the most brilliant in the world, but they were trapped by what they knew to be true. The Allies, pushed by desperation, were willing to bet on an idea that seemed to defy common sense, and that bet paid off. So why did the Axis ridicule Yankee terrain mapping? They ridiculed it because, based on their own successful long-wave radar technology, it was a physical impossibility. They were right according to their own rules. What they didn't know was that the Allies weren't just playing by the rules. They'd invented a whole new game. The cavity magnetron wasn't just an improvement, it was a quantum leap, a fundamental shift in what was possible. It's a story of ingenuity, of secret missions, and of the kind of quiet, brilliant work that changes the course of history. This history matters. These stories of ingenuity and perseverance are what made that generation great. And we believe now more than ever that we need to remember them. If you found value in this story and you'd like to help us continue to produce this kind of in-depth content, we invite you to join our community by subscribing. It's the best way to make sure you don't miss the next piece of history we uncover. The sheer, staggering scope of this technological shift is hard to fully grasp from our modern perspective, where we are surrounded by miracles. We have GPS in our pockets that can tell us where we are within a few feet anywhere on Earth. But in 1940, the best and brightest minds in the world were still struggling with the basic problem of finding a city from the air in bad weather. The gap between what the Axis knew and what the Allies did was not a small step. It was a chasm.
Let's dive a little deeper into the German perspective, because it's truly fascinating. The Germans were not idle in radar development. Their systems were, in many ways, more advanced than the early British chain home. The Würzburg radar, in particular, was a masterpiece of precision engineering. It was a parabolic dish, what we would recognize today as a radar dish, and it could lock onto a single bomber with pinpoint accuracy, feeding that data directly to the flak batteries below. The Germans were masters of fire control. Their entire air defense system, the Kammhuber line, was built on this technology. It was a brilliant but rigid system. But it was all built on the 53-centimeter wavelength. Their scientists, including brilliant men like Hans Hollmann, had actually patented a type of cavity magnetron back in 1935. But they ran into what they saw as insurmountable problems. They couldn't get high enough power out of it, and they found the signals were too easily absorbed by water vapor in the atmosphere, what we now call rain fade. They concluded it was a scientific curiosity, not a practical weapon of war. So they put it on the shelf. This was a critical and, as it turns out, fatal decision. They focused all their efforts on perfecting the 50-centimeter band, and they got very, very good at it. This is why the ridicule was so genuine. Imagine you are the world's foremost expert on building horse-drawn carriages. You've perfected the suspension, the materials, the aerodynamics. You build the finest, fastest carriages in the world. Then someone comes to you and says, I have an idea for a horseless carriage, but it's powered by setting off a series of small explosions inside a metal box. You would, quite reasonably, tell them they are insane. It's inefficient, it's dangerous, and it's absurd. The Germans were the world's best carriage makers. The Allies had just invented the internal combustion engine. The Americans at the MIT Rad Lab, funded with an almost unlimited budget, solved the problems the Germans couldn't. They figured out how to get massive power, kilowatts and later megawatts, out of a tiny magnetron. They figured out how to build receivers sensitive enough to catch the faint echoes. And they discovered that while rain was a problem, it wasn't a deal breaker. In fact, that problem was a feature. The radar could see through clouds, but it could also see the rain inside them, giving birth to weather radar. The Yankee contribution was not just the invention, but the industrialization and perfection of it at a speed that left the world breathless. Let's put ourselves back on that B-17, but this time, let's think about the crew. We often focus on the pilots, the flyboys, and the gunners. But for much of the war, the most important man on that plane was the navigator or the bombardier, the one hunched over the H2S scope. These men were a new breed. They had to learn to trust this flickering green screen more than their own eyes. They had to learn to read a new kind of map, a map of ghosts. A city was not a collection of streets. It was a bright patch of noise. A river was a dark, winding snake. They were interpreting a new language written in microwaves. And the Germans gave them no time to learn it. They were constantly trying to counter it. Once the Rotterdam Gerät was discovered, the Germans threw everything they had at the problem. They developed detectors like Naxos and Flensburg to try and home in on the H2S signals, but the Allies were relentless. As soon as the Germans found a way to detect the 10-centimeter radar, the Rad Lab had the 3-centimeter H2X version ready to go, which was invisible to the new German detectors. It was a game of cat and mouse, of measure and countermeasure, fought in the invisible electromagnetic spectrum. And the Allies, thanks to that 1940 head start, were always one crucial step ahead. This technological arms race had a profound human cost. Every new measure meant more lives lost on both sides as one side or the other gained a temporary, bloody advantage. But the magnetron's advantage was never truly temporary. It was fundamental. It allowed the Allies to press their attack relentlessly around the clock in all weather. It gave them an information advantage that the Axis could never, ever overcome. Without it, the D-Day landings would have been infinitely more difficult, as the preceding bombing campaign to isolate the beaches would have been crippled by the famously bad weather of the English Channel. It's also worth noting the sheer cultural shift this represented. For all of human history, night and weather were a shield. Armies rested, navies anchored, air forces were grounded. It was a time of safety, of respite. The magnetron radar destroyed that. It turned night into day. It made the clouds irrelevant. For the U-boat crews, the darkness was their only friend, the one time they could surface, recharge their batteries, and breathe fresh air. The magnetron radar stole their last refuge. It's a terrifying thought. It created a 24-hour, all-weather battlefield, the kind of relentless technological warfare that we now take for granted, but which was born in those desperate years. This brings us back to the core of the issue. The Axis ridicule was not just a mistake, it was a failure of imagination. They could not imagine a world where the rules they understood had been completely rewritten. And the Yankees, along with their British allies, were not just building better versions of old technology. They were building a new world. It's a story that feels intensely personal to us as Americans. It's in our national character, that spirit of innovation, of refusing to accept that something is impossible. We've been a nation of tinkerers and engineers since our founding. From the cotton gin to the telephone, from the assembly line to the Apollo program, the MIT Rad Lab was that spirit weaponized.
It's fascinating to read the post-war interrogations of German scientists. They were, to a man, in awe of what the Rad Lab had accomplished. They admitted freely that they had been beaten, and beaten badly, in the radar war. They had been so focused on perfecting their own elegant, but ultimately limited systems that they missed the revolution happening right under their noses. They were laughed at the idea of mapping terrain with radar because, with their radar, it was indeed a joke. They just never imagined the Allies would show up with a punchline that powerful. And so, this humble, fist-sized piece of copper, born in secrecy in Britain and mass-produced in America, stands as one of the most important inventions of the 20th century. It not only mapped the terrain of enemy territory, it mapped the future of warfare, and in the process, mapped the future of our daily lives. The next time you're frustrated that your microwave is taking too long, just remember, you're using a piece of technology that baffled the world's most brilliant engineers and helped save the free world. It's a legacy worth remembering. Let's expand on that legacy, because it's not just about microwave ovens. The principles of high-resolution, centimeter radar are the foundation of so much of our modern life. When you get on an airplane, it's an H2X descendant in the nose of that plane that's painting a picture of the weather ahead, allowing the pilots to steer around dangerous storm cells. It's a descendant of the H2S that allows ships to navigate crowded harbors in thick fog, seeing the buoys and other vessels as bright spots on a dark screen. The very science of radio astronomy, our ability to map distant galaxies and understand the origins of the universe, was born when scientists pointed these new, powerful radars at the sky and started listening to the static of the cosmos. This is the part of the story that often gets overlooked. We focus on the battles, on the bombs and the bullets. But the real war, the one that truly dictates the rise and fall of nations, is often the war of ideas, the war fought in laboratories and on chalkboards. The men at the MIT Rad Lab were just as much on the front lines as the men in the B-17s. They were fighting with slide rules and soldering irons, and they were racing against an enemy that was just as smart, but not as imaginative. And what about the ridicule? It serves as a permanent cautionary tale. In the world of technology and defense, the most dangerous phrase in the language is, "it can't be done." The Germans knew it couldn't be done. They had the math and the experiments to prove it. But the Allies, driven by the sheer existential need to survive, didn't have the luxury of accepting impossible. They had to find a way. This is the difference between innovation driven by confidence and innovation driven by desperation. The Germans were confident in their systems. The Allies were desperate for a new one. And as it turns out, desperation is a far more powerful motivator than confidence. Let's think about the men who had to use this. We've talked about the bombardier, but what about the maintenance crews on the ground? These were 19-year-old kids, many of whom had been working on farms or in gas stations just a year earlier. Now, they were handed a piece of technology that was light years beyond anything they had ever seen. It was delicate, temperamental, and absolutely essential. They had to learn to repair it in freezing cold Nissen huts in England with frozen fingers, working from manuals that were being written and rewritten almost weekly. The Yankee ingenuity wasn't just in the design. It was in the incredible, unglamorous, tireless work of the ground crews who kept those impossible machines running night after night. When we talk about this, it's easy to get lost in the technical details, but at its heart, this is a human story. It's a story of young men flying into unimaginable danger, putting their faith in a little green circle of light. It's a story of scientists working 20-hour days, fueled by coffee and the knowledge that every day they saved could mean thousands of lives saved. And it's a story of an enemy, brilliant and proud, being completely, utterly, and fatally blindsided. This piece of history is especially important for us today. We live in an age of rapid technological change, and we often hear people say that something, in computing, in medicine, in energy, is impossible. The story of the Magnetron is the ultimate counter-argument. It's the definitive proof that the impossible is just a temporary state. It's a problem that hasn't found the right, desperate, imaginative mind to solve it. The Germans ridiculed the idea of mapping terrain from the sky because they were looking at the world through the lens of the present. The Allies won because they were building the lens that would see the future. This story is a cornerstone of the Allied victory, and it's one we are proud to tell. The lessons of that generation, their courage, their sacrifice, and their sheer stubborn ingenuity are what we are all about here. We hope you found this journey into the past to be worthwhile. We have many more of these stories, tales of forgotten technology and unsung heroes, right here on the channel. If you're new, we'd be honored if you'd stick around. Let's circle back to that moment of discovery, that crash site in Rotterdam. It's a scene that plays out like a movie. For months, German intelligence had been collecting strange reports. Their night fighters, guided by their Würzburg radars, would be vectored onto a British bomber only for the bomber to suddenly and violently evade, before the fighter was in visual range. How could they know? Their own planes had no airborne warning radar. Then the bombing accuracy. Cities far from the coast, deep in Germany, were being hit with precision on nights with 100% cloud cover. It made no sense. Reports from captured alien airmen were dismissed as propaganda or lies. Then came the Rotterdam device. When the German scientists laid it on their lab bench, their blood ran cold. It was small, it was self-contained, and it was generating power at a frequency they thought was unusable. They immediately understood everything. They understood the accurate bombing, they understood the U-boat losses, they understood how their night fighters were being seen in the dark. It was in a single moment a complete and total unraveling of their entire air defense strategy. General Martini, the man who led the recovery team, had to report this to his superiors, all the way up to Goering and Hitler. Imagine that conversation. Imagine having to tell the leaders of the Reich that every radar set they had, every detector, every single piece of their multi-billion Reichmark defense system was now obsolete. All because of a piece of copper the size of a fist that the Allies were now mass-producing by the tens of thousands. The Ridiculed had been replaced by a frantic, panicked scramble. They created a special commission. They pulled their best scientists from every other project. But it was too late. The Yankee and British production lines were in full swing. The Rad Lab was already working on the next generation. This is the true nature of a technological advantage. It's not just about having a better piece of equipment. It's about having a better process for creating it. The Axis had brilliant scientists, but they were in a rigid top-down system. The Rad Lab was a whirlwind of academic freedom and industrial power, a unique combination that could only have happened in America. It was a place where a professor from Columbia, a radio engineer from Bell Labs, and a young physics graduate from Caltech could all be in the same room, arguing, testing, and building, with the full backing of the US government.
This is the Yankee ingenuity the title talks about. It wasn't just one person, it was a system of ingenuity. It was the ability to take a brilliant British idea, recognize its potential, and turn it into a rugged, reliable, mass-produced weapon of war in less than 2 years. The Germans might have ridiculed the idea of terrain mapping, but what they truly failed to appreciate was the speed at which the Allies could turn an idea into a reality. And for the men in the 65 and over generation, many of whom worked in the post-war industrial boom, this story resonates. It's a story about making things. It's about American industry rolling up its sleeves and solving a problem, not just with ideas, but with factories, with production lines, and with the sheer will to get the job done. It's a story that feels like it's in our DNA. Let's not forget the human element on the other side. What was it like to be a German U-boat commander in 1943? In 1941, you were the king of the Atlantic. You were a wolf, stalking the convoys at your leisure. By 1943, you were the prey. You were trapped in a steel coffin, terrified of the night, knowing that at any second, a blinding white light could snap on, and that would be the end. The psychological toll was immense. It's said that the morale of the U-boat crews completely collapsed in a matter of months. They called it Black May of 1943, the month the war in the Atlantic was truly lost for them, all thanks to a device they never saw coming. And what of the German citizens? The air raid sirens would wail, but they would look outside and see nothing but rain and thick clouds. They would head to the shelters, grumbling about a false alarm. Then the bombs would fall, right on target. The psychological effect of this all-seeing eye was terrifying. There was no escape, there was no hiding place. The Allies were not just destroying factories, they were destroying the will to fight by demonstrating a technological power that seemed almost supernatural.
So when we ask why did they ridicule it, the answer is simple and profoundly human. They ridiculed it because it was outside their experience. It was beyond their imagination. They were victims of their own success. Their mastery of 1930s technology blinded them to the possibilities of the 1940s, and the Yankees, along with the British, the newcomers to the game, were the ones who saw the future and, more importantly, had the industrial might and the intellectual freedom to build it. This story is more than just a piece of military trivia. It's a lesson in humility, in the dangers of arrogance, and in the incredible power of innovation when it's fueled by a desperate, unified purpose. It's one of the defining stories of the Second World War. Even if it was one of the most closely guarded secrets, it was quite simply the weapon that allowed the Allies to see. And in a war of the blind, the man with one eye is king. The Allies, thanks to the Magnetron, had two. The ripple effects of this one invention are still shaping our world. The entire field of electronics was kickstarted by this wartime effort. The men who worked at the MIT Rad Lab went on to found some of the most important technology companies of the 20th century. They took the lessons they learned about microwaves, about systems integration, about rapid prototyping, and they built the modern world with it. Every time you use your cell phone, which communicates using microwaves, you are touching the legacy of the Tizard Mission. Every time you watch a satellite weather forecast, you are seeing the world through the eyes of the H2X radar. This is why we tell these stories, because the past is never truly past. It's living all around us, in the very devices we use every day. And for those of us who lived through the Cold War, who saw the space race, who remembered the incredible pace of technological change in the 50s and 60s, this story feels familiar. It's the story of America at its best. It's the story of a challenge met, a problem solved, and a war won, not just with bravery, but with brilliance. It's a legacy to be proud of, and it's a legacy that should never be forgotten. This is the kind of history that deserves to be shared, and we hope you'll do that. Thank you for joining us on this journey. We know your time is valuable, and we appreciate you spending it with us. We'll see you on the next one. If you're new here, clicking that subscribe button is the best way to make sure you're the first to know when our next piece of history is ready.